Hello, welcome to my channel. In this video, we are going to be taking a look at the theory of converting AC to DC. Now, this particular concept is usually common in our day-to-day life. In particular, we see devices that connect alternating current to direct current in our day-to-day life. For example, on our phone charger, we can convert the alternating current that comes from the main switch to direct current that is needed by our phone. Likewise, our laptop, right? Our laptop is connected to the main switch and the alternating current that comes out is converted to direct current by the power pack, and the direct current is now being used by our laptop, and so on and so forth. So many of them, right? So let's take a look at one of the devices. A rectifier is a device that converts the alternating current to direct current, right? Then rectifiers can be found in our phone chargers, in our power pack of our laptop, and so on and so forth. Then one of the key components of a rectifier is a diode. A diode is a device that allows the flow of currents through one direction, but does not allow the flow of currents through the other direction. So if we have a diagram of a diode connected to a battery source in this form, so this is a symbol of a diode. If a current flows through its parts, this diode will allow it to flow through and it will be complete. But if we connect a diode in this other way, current cannot flow through. And if this particular voltage source is even high, it might damage it. So a diode will not allow a current to flow through this other side. So this side is taken as a negative, while this side is taken as positive. Okay, so we also have that there are several types of rectifiers, right? Two of them in particular, which is the half-wave and the full-wave rectifiers. So the half-wave rectifier and the full-wave rectifier. So this full-wave rectifier does what we want. This one does not do what we want. So under the full-wave, we have two types. We have the center tap full wave and the bridge full wave. So we have them in this form. Then out of these two, we are going to discuss this one. Now under this one, there are 4 stages, right, of this rectification. 4 stages of the rectification. The first one, we have it as the step down, the rectifier, the filtering, and the regulator, right? These 4 stages must be passed through for you to convert alternating current to direct current. Now, in the form of a diagram, let's depict these stages. So we have the initial source of the voltage, which is an alternating current. You can see how high it is. Then it is stepped down by a transformer, which is, you can see it's smaller than this. So at this point, it goes through a rectifier. We rectify it, all this negative becomes positive, which is this stage. Then at this point, it goes through filtering. Then the filtering will smoothen or will kind of reduce it to this form. Then it goes through regulator and it becomes this one. So our aim in this video is to see how we can convert this source of alternating current to a direct current needed by our phones, laptops, and other devices, right? So we have the step down, the rectification explained under this slide. So we have initially that our transformer, which is a device that converts high voltage from the wall outlet to a low voltage with the help of this same device. Then the rectification is one of the AC voltage that is transformed. It is then passed through a rectifier. This rectifier converts the AC voltage into pulsating device voltage by allowing current flow in one direction and removing the negative portion of the AC. So we have a diagram of this form, which allows current or alternating voltage to go through it from this end. And finally, we get these particular results, right? This is the first stage of the rectification, right? Now, let's see how we get this one from here. So what we do is, this first part, which is the positive part of the voltage, goes through this rectifier, right? And when it goes through, here becomes positive, here becomes negative, and in so doing, current will flow through this direction and end up in the same direction. So we start with the current that flows through this direction. When it gets to this point, it sees this and it sees this. It knows that there is a blockage here. So it goes through this one. So at this point, when it gets to this point, it sees that there is a blockage here. So it rather goes through this point. That's through the load. So going through this load, we see that this part will be seen. Now from this load, it goes through the ground and comes through the back through this part to complete the circle. So at this point, it goes through, and when it sees this and this, instead of it to go through this part, which will not form a complete loop, it will rather go through this part. And so we have it as through D3, then finally back to the negative end. Now, when this negative part is also, it's time for the negative part to go through this part, then here becomes positive and here becomes negative. And because here becomes positive, this is where the current will leave. So the current here will go through this direction. It gets to this point, it flows through this direction because here we oppose the flow. So we have it at this point. So when it gets to this point, it sees this one as an opposition because this one will not allow current to flow through in this direction. So it will rather go through the load. So from this load, the current will pass through this point, which will complete this circle. And we have it. So instead of it to go through this part again, it will rather go through this one because it came from this one has to complete the loop because it has to end at the negative. So we have going through D4 in this direction, and that's it. So that's how we get this negative. So this load, we see it as a positive loop. So this same process will occur over and over. So all the positive, this one will produce this one, this down one will produce this one here will produce this down one will produce this, and so on and so forth. So we'll go to the next stage and see what we can do to this particular source signal. So this is a filtering process. So for the filtering process, after rectifying, a filter is used to smoothing out and minimize the pulsating DC voltage. Typically, due to their ability to store charge, capacitors are used in this kind of filtering process. So we connect the capacitor to this particular load in this form. So this is our capacitor connected to the load in parallel. It is connected in parallel to this load, right? Okay. And remember that our source was like this, right? So what happens to this one? So we have it as this particular one. Once the current flows through this point, it charges this one and it goes through this one. So as the current is gradually increasing, it gets to this point. This particular capacitor is already charged. As this particular current is flowing, because they are connected in parallel, this one is charging and this one is gradually increasing. As it gets to this point that it's about to reduce, as the voltage source is reducing, this particular capacitor will discharge itself to compensate for this. And that discharge is given by this expression, this line here. So when this one discharges itself, it will continue. It will be enough for this particular resistors to, when the particular other parts of the signal is increasing, it will meet up at this point. So this particular load we start receiving signal from this point. So it will start increasing. And when it gets to the point, that point that we use to increase, it is also enough to charge up this capacitor. So when it is discharging, right, when this particular resistor, the voltage is reducing, this one will discharge itself and we have a signal of this form continuously. So this process will continue. So in a nutshell, this one discharges itself when it notices that the voltage in this one is about to reduce. So this one will discharge itself to compensate for that particular. And we have something of this form, which reduces to something of this form, this kind of signal. So we can see that at this point, we've not gotten the straight line, which is our aim. So we'll move on to the next step, which is the voltage regulation. So under voltage regulation, it's a device that is connected in order to ensure a constant and stable DC voltage output, compensating for fluctuations in the load or input load. So this is a device called a voltage regulator, right? It has 3 pins. One is connected to the input, one is connected to the ground, that's this one, while this one is connected to the output. So let's see how the diagram looks. So we have the setup in this form. We have our initial capacitor. This is the regulator. This part is connected to this one. This one is connected to the ground, while this other part is connected to the output. It is also advisable to add another capacitor here, just to serve as filtering to smoothen if there is any possible fluctuation, right? So we have this particular shape initially, right? So as this particular source of signal is seen here, right? This voltage regulator, because this is what comes out of these capacitors. So this voltage regulator smoothens it, and we have something of this form. It smoothens it. It only allows a direct current voltage to flow through it, this one. And the same process also, as long as the up and down signal goes through this part, it sees it as this. We have this, we have this. That's our source of voltage regulator. It smoothens it. And this is what we'll be seeing in the load. And we finally have this one as our direct current. And that's how the theory works, how to convert alternating current to direct current. I hope this helps. Please like, share, and subscribe to the channel. Thank you.